friction definition, examples, activities, and also factors affecting friction. Okay students, tell me how many factors affecting friction. I will write on the board factors affecting friction. Factors affecting friction. How many factors affecting? Yes, 3 types. What are they? First one is type of surface. Types of surface. Already we learned in the last class how many types of surfaces are you know? Yes, 2 types. What are they? Rough surface and smooth surface. Rough surface and smooth surface. Here, in which surface friction is very high? Yes, very good. In rough surface, friction is high. More friction. In smooth surface, less friction. Okay, this is the first factor. In these types of surfaces, friction is very high in rough surface. Very good. What is the second one? Weight of the body. Weight of the body. What is the third one? Area of contact. These 3 factors are we learned in last class. Okay? Here these 2 activities are we discussed in last topic. Here we observe area of contact. In this situation, friction does not depend on the area. Okay? Friction does not depend. Friction does not depend upon the area. Okay? These 3 factors we learned in last class. Today, let me explaining about types of frictions. Okay? Before we are going to listen the lesson, all of you bring your 8th class physics textbook and don't forget the write on the notes what I am saying in this class. Okay students? In last class already I said types of friction. Tell me the students. All are know the names of friction. Tell me the children. First one is very good, static friction. Static friction. What is the second one? Sliding friction. Last but one, rolling friction. Last one is fluid friction. Or drag out also. Read picture or brand. Now, we learn these type of frictions through videos. So students, now first we watch the video about first one is static friction.
This lesson with a question. I asked you if the force of friction comes into play only when the two things are in relative motion. Let's discuss this in detail. Let's say you want to move the stationary sofa in your living room and the sofa is really heavy. What happens when you give it an initial push? Yes, you're right. Nothing happens. The sofa doesn't move even though you're applying a lot of force. Why do you think the sofa doesn't move? Well, the answer is static friction. The force that you apply is balanced by a frictional force by the floor. And this force is applied in the direction opposite to your push. This force is nothing but static friction. The concept of static friction is really amazing. Why do I say that? The reason why I say that is because it is a self-adjusting force. As you increase your force of push, the force of static friction increases too, and the forces are still balanced. Now I know what you must be thinking. After a few seconds, the sofa begins to move, right? What happens to the static force then? Let's discuss this with the help of a simple graph. We assume that the force you apply is a horizontal force represented by the x-axis, and the frictional force applied by the floor is represented by the y-axis. Now, as you increase the horizontal force applied, the frictional force is also increasing accordingly to keep the sofa at rest. This continues till a point where the sofa just starts moving. And that's where the static friction ends and the sliding friction begins. The sliding friction is more or less constant if you notice. This part of the graph is static friction. It's when the sofa is not moving in spite of the force you're applying. And this part of the graph is sliding or kinetic friction when the sofa begins to move. The point around which the sofa just begins the movement is called the breakaway point. Is there anything else you noticed in the graph? Why is this line at a lower level than the maximum static frictional force? The reason is simple. If you've ever pushed a sofa or some heavy object on the floor, you would have realized that pushing it is a little easier when it's in motion. Yes, it's because the sliding friction is lesser than the static friction that's offered by the floor. That was the concept of static friction for you. So we've seen three kinds of friction so far: static friction, sliding friction, and rolling friction. Can you place them in the increasing order of force being applied by each? Yes, static friction is more than the sliding friction, which will be more than the rolling friction. In all the examples we've seen so far, we've only considered friction between solid parts: ball on a floor, box on a table, or roller skates on the ground. In all cases, both the objects were solid. Does friction come into play only when solid parts are involved? Is there any other kind of friction we haven't seen yet? Do watch our next video to know more.
Okay children, understood about static friction and sliding friction? Very good. Now we watch another video about rolling friction. Third one, rolling friction.
Have this cuboid shaped box placed on the table. Try pushing it a little. You will require some force to push it forward. Now place this same box on top of cylindrical shaped pencils and push it. What do you notice? You will notice that the force required by you to push it to the same point as before will be lesser. Why is that? Do the pencils reduce the friction between the box and the table? Absolutely. But it's not about the pencils, it's about the shape of the pencils. They are cylindrical. Assume you are traveling to another city and you are carrying luggage weighing around 25 kilograms. If you're unable to carry the bag, the only option you have is to drag it on the floor. but you will still require a lot of effort to drag your bag. But what if your luggage had wheels under it? Won't it be far easier to carry it around? Yes, it'll be easier. But the question is why? Why is it easier to roll a box over cylindrical pencils relative to pushing it on a flat surface? Why is it easier to carry the bag around when it has rollers under it? Hold on to this thought. I'll come back to it. Before we discuss the above situations, we need to understand what sliding friction is. The concept is simple. It is the frictional force which opposes the relative sliding motion between the two surfaces in contact. What does this mean in simple words? It simply means that if an object is in motion on a surface, the frictional force that is offered by the surface is called the sliding friction. The key words here are sliding motion. The two surfaces have to be in relative motion with each other. In our example, when a box is moving on the table, we say that the box is in relative motion with the table. The resistive force applied by the table when the box is moving is called sliding friction. Remember, the objects have to be in relative motion. Because there's movement involved, this force is also called kinetic friction. Now consider the example of the luggage in which we don't have the wheels under it. When we move the luggage, what will the resistive force applied by the ground be called? Yes, sliding friction. But what happens when we attach circular wheels at the bottom of the luggage? Yes, the friction gets reduced to a great extent. This type of friction which arises when an object is rolled on a surface is called rolling friction. It is a force associated with rotational movement. Now can you tell me by pure intuition about which force will be lesser? Sliding friction or rolling friction? Yes, rolling friction is usually lesser than the one associated with sliding friction. And that's why attaching wheels at the bottom makes it easier to move the object around. And similarly, moving the box on top of the cylindrical pencils is also easier. Can you think of more examples where the concept of rolling friction is used to reduce the friction? Yes, tires of your car. When the car is in motion, the ground applies a force of resistance which is nothing but rolling friction on the tires. Do you remember seeing ball bearings? They are spherical metal balls used in many mechanical structures which have moving parts. They're generally made up of stainless steel, brass or ceramic. They reduce friction to a great extent, which in turn reduces the wear and tear of machine parts. So we got the concept of sliding and rolling friction. There is another interesting type of friction which we need to know about. Will the force of friction come into play only when the two things are in relative motion? Not necessarily. To know which kind of friction I'm talking about, watch our next video.
All are understood about static friction, sliding friction and rolling friction through videos. Let us learn about fluid friction through another video.
Only between solid parts? Not necessarily. Friction is offered by fluids like air and water as well. And this force of friction due to fluids is referred to as a fluid friction. The friction we've seen between solid parts is referred to as dry friction. The major states of matter are solid, liquid and gas. And liquids and gases are generally referred to as fluids. Why are liquids and gases considered to be fluids? One common characteristic of fluids is that they have no fixed shape and can be easily deformed. Let's discuss a bit more about fluid friction in this lesson. Just like solids, fluids too exert a force of friction when objects move through them. Do you think air offers resistance? Doesn't seem intuitive, right? When I drop a stone from a particular height, it falls to the ground. Does air offer resistance here? Of course it does. What about water? Does it offer resistance? Yes, when the fish swim, they encounter fluid resistance from the water. The frictional force exerted by fluids is also referred to as drag. What does fluid friction depend on? Let's talk about the first obvious factor. It's the nature of the fluid. To understand this point, you just need to answer a simple question. An object moves from point A to B through air, and in the second case, a similar object travels from A to B through water. Which object do you think encounters more resistance? Clearly, it will be the water, right? Yes, more the thickness of the fluid, greater will be the frictional force acting on an object which moves through it. There's a term which describes a fluid's resistance to flow. It's called viscosity. So here we can say that the water is more viscous than air. Higher the viscosity, more will be the resistance offered by that fluid. Honey is more viscous than water, which is why it offers more friction than water. That was the first factor affecting fluid friction, the nature of the fluid. Can you think of any other factor? Another factor is the speed with which the object is traveling. Higher the speed of the object moving through a fluid, greater will be the frictional force acting on it. A vehicle traveling at 100 miles per hour will face more drag of air as compared to a similar vehicle traveling at 50 miles per hour. Apart from the nature of the fluid and the speed with which the object is traveling, is there any other factor on which fluid friction depends on? Yes, it also depends on the shape of the object. And it's really important that we understand this factor well. Have you ever thought about why aeroplanes are shaped like this? It could just have been a rectangular box flying in the air. How have the fish evolved to be shaped like this? Why are the ships designed to be given this shape? There's a reason for all this. They're given a streamlined shape to minimize the fluid friction. The shape of the aeroplane, if you notice, is like that of a bird. This process of giving an object a particular shape to decrease the fluid friction is known as streamlining. Streamlining the object can greatly reduce the resistance offered by the fluid. A car faces lesser friction from air as it has a streamlined shape. A bus, on the other hand, will face more air friction as it doesn't have a streamlined shape. So these were the different factors on which fluid friction depends. Nature of the fluid, the speed of the object flowing through the fluid, and the shape of the object.
Afterwards, these types of frictions through videos, I think all are understood the children, these videos. Then we concluded that here all of you understand what is static friction? Static means rest. What is that? Static means rest. That means the object in constant position. Okay? Then we concluded that always static friction is greater than sliding friction. I will write on the board. All of you note down in our running notes also. Static friction is greater than sliding friction. Static friction is greater than sliding friction and again greater than rolling friction. Rolling friction. In case of static friction, the object is at rest. The object is at rest. All of you know down children. In case of static friction, the object is at rest position. In case of sliding friction, it can be moved. Object and moves. It starts to begin move. Next, third one, rolling friction. In this case, Children, now we are going to discuss about the very interesting topic, that is friction is necessary. What is that? Friction is necessary. Friction is necessary. See children, friction is needed to do anything for daily activities. Yes, definitely you want the friction. For example, there is no friction, we can't able to walk on the road. There is no friction, we can't able to write on the board or write on the paper with pencil or pen. There is no friction to fix a nail on the wall. And also there is no friction to construct the new buildings also. Okay? That's why we concluded that the friction is very important in our daily life activities. Without friction, the daily activities are not at all for simple. So, in this manner, the friction have characteristic also. What is that? Friction produce heat. What is that? Friction produce heat. Produce heat. Friction produce heat. This concept is explained through the activity. Okay children? In winter season, the weather was very cold. How do you feel? Immediately, we take your palms and rub the palms and put on a cheek. Why behaving like this? For hotness. For hotness. Okay? Children, in this way, I am doing the activity. I will do the activity. You also do after me. Okay? All of you take your two palms. Very good. Then rub the two palms together. After, for some time. Rub the two palms for some time. What do you observe in this case? All of you say the answer. What do you? Here the heat is produced. That means the heat is generated between the two palms. Okay. That means the friction is produced between due to the friction, the heat is produced between the two palms, two surfaces of the palms. Then we concluded that the characteristic of friction produce the heat. Okay. Next, we are going to learn a new topic also. What is that? How to reduce the friction. What is that? How to reduce the friction. For sometimes you want friction. We need the friction. But for sometimes we have to reduce the friction for protecting our body. Okay? What is the new topic? How to reduce the friction. How to reduce the friction. How to reduce the friction. For three types, we have to reduce the friction. First one is softness surface. What is that? All of children, all of you note down in your notebook. Okay? How to reduce the friction? First one is softness surface. Softness surface. What is that? Softness surface. We take the softness surface, automatically we can reduce the friction. All are know in both surfaces, in both cases we have to reduce friction in a smooth surface only. Why? Because rough surface having the more friction. So we can take the soft surface, then we can reduce the friction. Then go to second one. What is that? Using powders. Using powders. How to use the powders and how to reduce the friction, I will show activity for better understanding. Children, all are the carrom board game? Yes, I am so interested to play the carrom board game. In this activity, I want to show the carrom board game for activity purpose. All are see the carrom board. In this case, I want to play the game for activity. Take the coins. Take the coins. Here, all of you observe what I am doing here. Okay, children? I am taking carrom board, and in this case, I want to hit the coins. Okay? All of you see, I hit the coins with the strider. All of you observe very clearly. I hit the coins. Here, what you observe? I want to hit the coins. The coins are moving freely in specific direction what I am expecting. So, what will you do? Then, I want to apply the powder. I want to use the powder on the board for softness, moving the coins freely. The motion of the coins freely. Then again I want to play the game. Here I want to hit the coin with the strider. All of you observe. Then here what we observe? Observing here the coins are freely moves and go to in the hole because of softness of the surface. Here by using the powder, then the surface are going to smooth. Then easily we hit the coins. Okay children, you understood the activity? Next, we are going to the third one. We are going to the third one. What is that? Lubricants. By using lubricants. Okay, children, do you understand? First one is softness surface, second one is using powder, third one is lubricants. This third one is very important. Important because the machines are, we have more number of wheels. Okay? More number of, it is constructed with more number of wheels. In those wheels, the vehicles are moved to walking position. That means the vehicles are in a motion. Okay. Then what happened? The vehicles are using for a long time. That means 1 year, 2 years and 3 years. What happened? the vehicles, that means the vehicles used for a long time, the wheels are not working properly. Okay, understand the children? The wheels are working not properly. In that situation, we have to use the oils or grease. Oils or grease. Oils or greases and greases. Oils and grease. All are the oils. Some oils are for using the purpose of machines. For some oils having the machines. So, in this case, in machines, the lubricants are using for the free moving wheels. Okay, children? And going to the simple example, all are know in that case, we are going to the newly constructed building. Okay? See the doors. All are know the doors are attached on the wall with by using hinges. The doors are attached with hinges. We want to push or pull the door. Okay, children? Understand what I am saying? We want to push the door or pull the door. What we have observed in that situation? There is we will get a noisy sound from the hinges, from doors. Then after some time, that means 3 months or 6 months, when again we want to push the door and door, we want to push or pull the door. Then what will we get? There is a noisy, we will get a noisy sound from the doors. Okay, children, there is a noisy sound from the doors. In our houses, your mother or father, what will you do? What will do in that case? Then by using oils, pour the oils on the hinges of the door. When you want to pour the oils on the hinges, then the doors are freely moves. Okay, children, understand? Freely moves the doors. In this case, for reducing the friction, we want to use the lubricants. What is that? We want to use lubricants. Then in both cases, machines also and doors also, we want to use the lubricants. We have to reduce the friction in both cases. We can conclude that how to reduce the friction means we have to follow the softness of surface and using powders and lubricants we can reduce the friction in our daily life. Okay, children? Then for sometimes we need mostly the friction for doing the daily activities. For sometimes we have to reduce the friction, already we discussed. In some cases, we want to increase the friction also. What is that? We want to increase the friction also. How to increase the friction? How to increase the friction, children? By using how to increase the friction. How to increase the friction means we are going to playground we wear the some shoes, sports shoe. All are know. In sports shoe, we have to observe the sports shoe. Under the sports shoe is designed with some shapes. All of you look at the board. It's a shoe. Under shape. This shoe is designed with some shapes. All of you check your sports shoe also. The shoe is designed with some shapes that are known as grooves. What are they? Grooves. What is that? Grooves. Grooves. This design is nothing but grooves. Here, why the shoe is designed like this? Means we have to increase the friction in this case. Okay, children, we have to increase the friction in this case for not slippery. For example, మనము ప్లే గ్రౌండ్ కి వాకింగ్ చేయడానికి వెళ్ళినప్పుడు షూ వాడతాం. ఆ షూస్ మనం అబ్జర్వ్ చేసినట్లయితే అడుగు భాగంలో ఇలా డిజైన్ చేసి ఉంటుంది. దాన్నే మనం గ్రూవ్స్ అంటాం. అదే స్మూత్ సర్ఫేస్ దగ్గర ఈ గ్రూవ్స్ లేకుండా షూస్ వేసుకుంటే ఆటోమేటిక్ గా స్లిప్ అయిపోతుంది. సో వీ హ్యావ్ టు యూజ్ ది స్పెసిఫిక్ షూ ఫర్ sports in a playground. Okay, due to this, in this case we have to use the sports shoe for not slipping. Okay, children, in this case increase the friction. Okay, in this case we have to increase the friction. In the second case we observe types of the vehicles. All are the types of the vehicles, children? Okay. Types of vehicles also designed with some shapes, triangular shapes, rectangular shapes. Type. These all vehicles types are designed with some triangular shape structure. This triangular shape structure is nothing but threading. What is that? Threading. We are using the structure of threading ties. We have to increase the structure. Why? Because we are moving on the road. There is no friction or the road, the ties are smoothness. We are immediately skid the vehicles. Then occurs the accidents. Okay. So why? Because we are using the threadings or ties. These are commonly designed with the threading. Why? Because to increase the friction. Increase the friction, we use the threading ties. There is no friction, the accidents are occurs. We are unable to drive or we are unable to travel on the vehicles in a road. So in these two cases, in one case we are using the grooves with the shoes and second one is traveling vehicles is designed with the threading. In both cases we increase the friction. Okay, children, I feel that we are all understood the today's topic. Okay, what you have learned in this class, just remember, first one is friction is necessary. Second, how to increase the friction. Third one, how to reduce the friction. And also types of worksheet. All of you note down your class notes. All of you keep the heading worksheet 2. Worksheet 2. What is the first one? How many types of friction? Explain. Then second one. What is friction? Second one. What is friction? All of you note down the questions, students. Third one. How to reduce friction? How to reduce the friction in daily life? Next, write the activity. Write the activity about production of heat. Okay, children, all of you try to answer these questions. Then, in pandemic situation, all of you stay at home. Diary